Okay, guys, I'm so sorry about that and that we did experience some technical difficulty, but at least we didn't just leave you there being like, remember back in the days on the TVs with the little screen or the intermission or the beep. At least I didn't leave you with that, so I'm happy. Last but certainly not least, we have Laura Nolan, who is going to be joining us shortly. Laura, this is actually, I'm really happy about this because this is the second time I actually get to introduce Laura at a talk. And I remember her at ShipItCon as well 2 years ago. Amazing. So this is a great, like, it's like deja vu all over again. And I'm so hyped and I'm so excited to be here with you guys, as well as introducing these amazing ass people. Like, oh my God. So without further ado, Laura Nolan is a software engineer focused on distributed systems reliability, who contributed to the best-selling Google SRE book, and more recently to 97 Things Every SRE Should Know. Laura is a member of the Usenix Association Board and is currently a DCU student, part-time, Master of Arts in Ethics. You hear that? Best-selling. Clearly, Laura knows what it is, and she's about to drop some gems. So for our last speaker, please, let's get it. Laura, I'm going to get you to come on to us. We're so excited to have you on.
Correctly sharing audio and video. Great. Okay.
We got you.
Great. Hey, I'm so glad to be here. Give me like 2 seconds while I figure out how to share my correct application window, which should be this one. Hey, okay. Can you all see some slides that say managing the risk of cascading failure? Great. Okay. We'll begin. So like I say, thank you so much for having me. I'm so glad to be here. Particularly given that this is a student organized conference in Dublin, and you can probably tell from listening to me that I am Irish. I do live in Dublin and work here. And, I'm also a DCU student, weirdly enough. So, I'm really just happy to support this particular conference. So, cascading failure. First about me. So I just wanted to say one thing, actually. One of the reasons that I am here at DCU studying ethics is, besides all the things that were said at the start here, I'm a big supporter of a thing called the campaign Stop Killer Robots. A couple of years back, I was working at Google. They asked me to do some crazy stuff that involved blowing people up with drone strikes, and I said no. And I joined the campaign Stop Killer Robots instead. And that's why I no longer work at Google. But anyone who's interested in that sort of interesting tech ethics quagmire, that's the other thing that I do. So first, what are cascading failures? Basically, it's where you have some sort of complicated distributed system and you get a vicious cycle in it that causes like a feedback loop, essentially. And what happens is that feedback creates extra load, which basically will overload some parts of your systems, cause them to fail. And then the problem just gets worse because now you have less capacity to deal with that kind of failure. And we see this in computer systems, and we see it in computer networks, and we see it in electricity grids. And this is particularly topical because if you actually search for cascading failures, you'll get a whole bunch of papers about electricity grids. And of course, we're all seeing the situations in Texas at the moment. And Texas, people have talked about the fact that Texas has chosen to sort of split itself off from the remainder of the US's grid. It doesn't have these interconnections that could help it to weather these kinds of blips in its own supply. And part of the reason that they've done that, well, first of it is, politics, but part of it is to try and insulate itself from these cascading failures that can take down chunks of the electricity grid and then sort of spread. And there was a very big failure like that in the US East Coast in 2003. So it's just sort of interesting to see how partitioning yourself off to try and avoid this kind of failure can create another kind of failure. So let's go back to talking about software systems. So the context here is I'm talking about systems where you have large systems that are bigger than you can serve from just one single computer, one single server. So you need to split up the workload and you need to split up data sometimes as well. So you've got a bunch of back-end servers behind some sort of load balancing mechanism, and there's various different ways you can do this, varying from DNS to software load balancers to hardware load balancers, all sorts of things. But generally speaking, we design these systems so that if one part of the system fails, the traffic can be failed over to another part of the system. And that's normally a good thing, right? Because you want your users to still be able to do whatever they were trying to do, even though, say, one of your servers has failed, or maybe a rack of servers have failed, like maybe the top of rack switch went, or maybe maybe a whole data center has gone on fire. I mean, these things happen. So normal situations, it's good for you to be able to kind of fail over these requests to some other part of your system and still serve. But the flip side of this is that can create this cascading failure risk. So how the cascading failure risk, and this happens in this situation, is for some reason, you've lost some part of the capacity of your system, your clients will retry, and now the load is too much for the remaining parts of your system, and the whole thing goes down. And it stays down because anything that tries to restart and come up and serve just keeps getting flattened. So retrying and failing over, it's normally good, but in a situation where you are low on capacity for whatever reason, it creates this cascading failure risk. And these things are like, you can't have one without the other, right? It's like the light side of the force and the dark side of the force. Have one without the other, you cannot. You just have to make good choices to reduce that risk. So here's another way of thinking about it. Thinking about ideal client behavior in these two different cases I just talked about. If you have overload of just a subset of your system, you want to retry immediately because then your user doesn't have to wait around. But if you have a global overload situation where the whole system is overloaded, what the ideal client behavior should be is to actually back off and let those backends recover, or just fail immediately. The problem is that you, as a client, you don't actually know which situation you're in. You don't have that global knowledge, right? So you just have to do the best thing that you can. And this is really, really important for those of you who are in the audience who may be kind of, starting off in your careers, because I can guarantee you this: in your career, you will write a lot more client software than server software, almost certainly, at least I have. So this is the thing that's actually really important to get right. So what we do most of the time is you'll sort of either, retry maybe a limited number of times, 1, 2, 3 times. What's nice is to increase the time between those retries in case you're in the global overload scenario. But there's a lot of pitfalls to this, right? You can have a complex multi-layered system where, you might have 2 or 3 different tiers, and maybe a load balancer tier as well. And it's very easy to wind up in a situation where a client retries 3 times, and then your load balancer retries 3 times, and then the first piece of software, like a web tier, might retry 3 times, and then you can end up with like 27 requests hitting an overloaded backend to that system, maybe a database. So you have this kind of exponential growth in retries, which is one of these big contributors to this cascading failure phenomenon. So you have to be quite careful where you're doing your retries. If you're doing your retries at a load balancer layer, don't also do them at the client layer, and so on. So that's important to know. I'm going to talk about a real world example of an actual cascading failure outage. This is Amazon Web Services, and I've put a little link here in the slide, and I will hand these slides to the organizers of the conference after this talk, and hopefully they can put them up somewhere. But if not, this whole talk is based on an article that's on InfoQ called, just Google my name and cascading failure, and you should find it. And the link is in there. So Amazon's DynamoDB service is one of Amazon's pretty old, pretty reliable services. It's basically a big key value store, eventually consistent. So the core architecture, like you see here, is you have storage servers that actually, serve and store the keys and values. And then you have this replicated metadata service. And what this basically does is it organizes which sets of keys and values are on which storage server. So the storage servers have to basically check in with this service pretty frequently to make sure that they're still serving what they're supposed to be serving. And that's what this partition assignment thing is. So this is kind of the way the system is supposed to work. So in 2015, they had added a new type of index on this system. And what this had done is it had increased the load on the metadata service. So because the storage servers now had to make requests for this new type of index as well. So the latency, the average latency to fetch that metadata had increased because of the extra load on metadata service. And now it was pretty close to the deadline or the maximum time that the storage servers were going to allow for that request to complete. So they had this situation where they were on this kind of cliff edge. They didn't know they were on a cliff edge. They had not noticed, but they were on a cliff edge. And here's what happened. They had a short network failure, just something that blipped and came back. But for a short period of time, some of the storage servers couldn't get their partition assignments. So what they did was they continued to retry. So after the network came back, the replicated metadata service had this coordinated sort of wave of extra load, which hit it. And it wasn't able to serve all that load. What happened next is, that the instances of that metadata service, they became unhealthy because they were overloaded. Requests became slower, and none of the requests were completing in the time period that the storage servers were allowing. So this is the worst of all possible worlds, right? The storage servers are requesting the metadata. The work is being done on the replicated metadata service, but the storage servers aren't waiting long enough to get the answer, and they're trying again and adding even more load and doing no actual real work. So this is a cascading failure scenario. What they actually needed to do to get out of this situation was to add more replicas to the metadata service so that it could handle the extra load. The problem with this is the replicated metadata service instances that were already there, they were under so much load that they couldn't add more capacity, because to add more capacity requires the new servers to be able to sync state with the old existing servers. So they had to do something that's quite common when you get a cascading failure scenario, which is to basically physically block off the source of the load in your system. So what they effectively had to do was they had to take DynamoDB, a pretty significant AWS service, more offline for a period to repair it. So this is a thing called a causal loop diagram, which kind of, it gives like it puts a sort of theoretical like model on top of this thing. So this is probably something that I'm guessing 98% of you have not seen a causal loop diagram, which is a shame, because these things are really quite useful if you're thinking about how systems behave, which is basically my job. So causal loop diagrams come from a thing called system dynamics, which comes from sort of systems theory, which comes from actually World War II operations research, where they were trying to figure out how to do military things more efficiently. So you have these boxes, and each box is some sort of quantity, and you have these arrows between the boxes, and each of the arrows are going to have a plus or a minus. In this case, it's mostly pluses. So what the plus or the minus means is, for the arrow, is that if the thing on the from side of the arrow increases, then the thing on the to side of the arrow will tend to increase as well if it's a plus. And if it's a minus, the thing on the to side of the arrow will tend to decrease. So you can have a positive relationship or a negative, or like an inverse negative relationship. So in this case, we see that we have this sort of cycle in the middle of the graph where metadata service load, if that increases, then the latency increases. And if the latency increases, then the timeouts increase. And then if the timeouts increase, then the retries increase. And if the retries increase, then the load increases. So this is the basis of this feedback loop that we see here. And the reason that you have an or in the middle, that means that it's a reinforcing loop. And it's a reinforcing loop because you have an even number of pluses. So if you have an uneven number of pluses and minuses, then you have a balanced loop, which shouldn't have the runaway feedback property. So that's the mechanism for cascading failures. What's so bad about them? We've seen some of the reasons that they're bad. They take down your whole service, and they don't get better by themselves, and you don't really get a warning that you're on the brink of one of these things. It just sort of happens and you've tipped over into this bad state. So there's something that we'd really quite like to avoid. But if you can't avoid, you have to recover. So normally you can't just scale out of your cascading failure, because any new capacity that you bring up will tend to just get hit with the excess load. It'll get saturated and it will health check unhealthy, very often in your orchestration system, Kubernetes or whatever you're using, or in your load balancer. In some cases, you might end up having your instances of your service go out of memory or hang or get slow. So what you tend to have to do is something like what Amazon did in this situation. You have to reduce the load until you can get sufficient serving capacity in place. And then you might have to bring your load back up gradually on the service. So it's useful to know how it's possible to block things from accessing your service. So disabling health checks temporarily, if you're trying to recover from a cascading failure, can actually help quite a lot, because it can reduce this load of this effect of lasering load on whichever instances look the best right now, and it can sort of spread load and let things settle down. This is something that will make your colleagues look at you like you're a crazy person, turn off the health checks, but yeah, it can be really helpful. So if we want to avoid cascading failures, which you do, trust me, you can follow you can avoid certain anti-patterns. So the first anti-pattern is accepting an unbounded number of requests into any service that you write. So if anyone's ever done any load testing, and probably will at some point, there's a phenomenon that you notice where if you load an instance of any software system past its peak throughput, you'll start seeing a decline. So there's this very kind of characteristic load throughput curve that you get. And the reason for that is when you overload a service, it starts to have to spend more time kind of switching contexts as it tries to deal with too many parallel requests, or maybe it's trying to manage a long queue and it ends up having to do a bunch of memory management, stuff like this. So you can end up having instances of your services basically grind and get really slow, and that's bad. Sometimes you need to restart to get out of this situation, and that really extends any downtime, any outages that you have. This is also bad for clients, so things that are trying to use this system. Generally speaking, it's much better to fail fast than to wait a long time and have something time out. The reason for that is client systems, they have limitations as well in terms of thread pools or connection pools, and you can hit these limits as well. So we want to avoid that. So every instance and every service should really set some sort of limit on the load that it can accept. You can do this sometimes in load balancers. So Envoy Proxy will let you set the max number of incoming connections or requests to backend instances of your service. You can also do it in software. So, I mean, you can quite literally write a semaphore that will put a limit on the number of inbound requests that can be accepted and reject all others. So it's really useful to think about how you can do that in any piece of software that you write. This is one of the most fundamental sort of precepts of reliable software. Okay, second anti-pattern. For some reason, my slide advancing is very slow. I do apologize. So anti-pattern 2 is dangerous client retry behavior. So when you write client software, you have to be very, very mindful of this. Whenever we have control over the clients of our systems, we should use that to make our systems safer. So if a request is based on something a user did, something a user was waiting for, there's no point in retrying that a bunch of times. Retry it once, twice at most, and then fail with an error, because humans do not like to wait around. They're not going to wait for a long time anyway. If you're writing some sort of batch software, you probably want to do retries, because batch work, you probably want to do it at some point, but you can use really long backups here. Like you can have backups of up to several minutes in a sensible way. There's a pattern called a software pattern called the circuit breaker, which comes from Martin Fowler, and it's also described in a book by Michael T. Nygaard. And the basic idea of circuit breaker is to make application retries safer for your backends. So what you do is you use one circuit breaker for each instance of your application. So all of your serving threads will go through this one circuit breaker. And what a circuit breaker does is it looks at the success rate of requests to a backend. And if it notices that a bunch of requests fail in a row, that circuit breaker will close. And the closed circuit breaker will no longer make any requests to the backends. What it will do is it'll fail fast, so you can either fail the request outright or retry. And this is designed to protect backends from these surges of load. It's a very useful pattern. So a third anti-pattern is a thing called the poison pill, or query of death. And this is a thing that can cause cascading failures as well. So this mechanism is some query to your system coming from the outside world can cause your system to crash. So if a client sends a query of death or a poison pill, crashes the first instance of your service, retries, crashes the second, and so on and so forth. A few instances of that can be enough to really start taking down or really start reducing the capacity of your system, and then you get into this overload state. So what you can do about this is you basically write your software to never crash based on user input. If you get bad input from a user, you return an error. You do not crash. You should only crash your software if you have something catastrophically wrong in your internal state, and it's just for this reason. You can also have software that crashes unintentionally. So, triggering any sort of bug that would cause a crash. These obviously are more prevalent in software that is less memory safe, but this can happen in any kind of software really. So there's a technique called fuzzing that you can use, and a lot of software frameworks like gRPC, for example, and Thrift, I think as well, include some frameworks that you can use to write your own fuzzers. And what a fuzzer does is you bring up an instance of your system, usually in a test environment, and you throw all sorts of input at it, valid, invalid, all sorts of the whole spectrum, and you see if your software ever crashes. And this is something that is really a great idea to do if your software is exposed to the open internet or users who you don't control. It's a good idea regardless. I mean, it's if you have time to do it. So the fourth anti-pattern is a thing called proximity-based failover. So if you're running a global service, it's very common to want to terminate requests close to your users and serve as close to the user as possible, because this reduces latency, and reducing latency makes people happy. People like their things to be fast, and this can make you more money if you're making money out of your software. So there's good reasons to do this. The problem is if you design your systems to spill load from a failed data center to the next nearest one, you can end up with this sort of geographic cascading failure thing that can happen. So let's take, for example, in this situation, we've got 2 US East Coast data centers and 2 in the West, 2 in Europe, and some in APAC. So if you lost one of your US East Coast data centers, if you just naively spread load to the next nearest place, you're probably going to double the load on your second East Coast data center very quickly. So if it can't handle that load, now you've doubled the load on your 2 West Coast data centers, because the load's going to go there. And if they fail, probably you're going to your Singapore, I would think, from this diagram. But the point here is, if you have a setup like this, you have to make sure that one of these 2 things is true. The first thing that you can do is use your load balancing system to set some sort of limits on the amount of traffic that will be sent to any given data center. So this is a good example of the tool that you can use for this is NS1 has this geographic load balancing system that will let you set high watermarks for requests. And as you start to approach that, it will stop handing out the IP addresses for that geolocation in order to start reducing the load or stop increasing it. That's quite a useful thing. Some systems use a thing called IP Anycast, and this is very common if you're running DNS, because users are finding you based on IP, and you're serving the same IP from a number of different places around the world. In this case, you actually don't have any mechanism that lets you steer that load from place to place. So you just have to make sure that your capacity in each of your locations is high enough to deal with whatever comes, because you don't have any control over it. So my next anti-pattern is work that happens when something fails, right? So consider that we're running some sort of distributed data store system. It splits your data into blocks. We want to have at least 2 replicas of each block, or 3 replicas in this case. So this diagram shows that we have 3 replicas at the start. We lose the second server with the little lightning bolt on it. So what happens now is we have to copy the 2 blocks that were on that failed service so that we have 3 replicas again. That's fine. That's fine if it's one failure. This is very bad if you have a lot of failures all at once. And the reason that it's bad if you have a lot of failures all at once is that you get extra load on your remaining replicas at the same time that you get this big wave of extra work from the copying. So here's what this looks like in one of those causal loop diagrams. So we see that hardware power failure in the bottom left causes failed heartbeats. So the servers will see that the other replicas do not exist. This causes a wave of replication, which causes increased system load. And at the same time, the read load also causes system load, right? So we have another one of these reinforcing loops, right? And the reinforcing loop doesn't mean that we're always going to be in a bad state. It just means that we have the potential to get into that overload state, that feedback loop state in the wrong situation, which in this case could be a wave of failures. So the way that we normally fix this is we put a limit on the amount of replication work. So there's a thing called a token bucket algorithm, which is pretty much what it sounds like. And it's really widely used to implement throttling, quota over time. So conceptually, you have a bucket, which is just implemented as a counter for each operation, or maybe for each user. It depends how you set it up. And every time you do an operation, you decrement your bucket, and then over time, tokens get added back. So you get a certain amount of quota over time, and you can do a little bit of burst. This is a really, really, really useful mechanism, because any reliable system has to have a mechanism to rate limit costly operations. So add a token bucket into the system. You still have your reinforcing loop, but the token bucket loop is a balanced loop because it's got a plus and a minus, and you're decrementing tokens as you do replication. So that balanced loop acts as a brake on your overall reinforcing loop. So that gives you a system that can be trusted not to go crazy, basically. So a 6th anti-pattern that you should avoid is long startup times. So sometimes people will design a system that may, for example, cache a bunch of data whenever a new instance starts up. I would avoid that if you can, because first off, it makes scaling up quickly very hard. You can't scale up automatically in a predictable way to meet extra load. And if you have any sort of coordinated failure, like for example, particularly in the case where you're caching a bunch of stuff, you might go out of memory. That means that your system will be hard down with no capacity until such time as you can get all of those instances back up again after their long startup. So that's something to be avoided. Pardon me. So almost to the end here, on time. The thing to remember, where there is failover, there is a risk of cascading failure, because this mechanism where we retry to a potentially healthy backend or set of backends is what creates the risk of this extra wave of load that can take those backends down, right? You have to think about your system as a whole, not just one single backend, not even the set of them, but how it works together with your load balancing, how it works together with client retries, all these things. If you want to know more, this slide here, it links off to that article I mentioned, which has even quite a bit more detail on this kind of stuff. And I think we are pretty much ready to take some Q&A. Thank you so much.
I love hearing you speak, Laura, because you clearly come across as such an expert that you make me believe that I know what you're talking about, even though I don't. So I do really enjoy hearing you speak, because you honestly almost sound as if you are the inventor or the founder of when it comes to things such as technology and site reliability and things like that. So guys, I'm going to open up the floor for you guys to ask questions. This is our last speaker for the day. I actually can't believe it's almost over. So I would ask you guys just to throw in your questions in the Q&A. Just in regards to what Laura was just talking about. Nicole just wants to say thank you, Laura. I do have to say with today, Laura, a lot of our speakers, I think you guys have all just had so much information, and it's all been so valuable that anytime the speaker finishes, like, I think the audience is just trying to sit there being like, I think I got everything. I don't even think I can ask a question, because I'm still trying to process what I've learned today and what I'm taking away. So it's really, really good. So Fanila is saying that was super interesting. Oshin is also saying that was really great. The examples were all really clear. And I just remember as well from your last talk at ShipItCon, I think it had to do with the Black Swan. Is it the Black Swan?
That sounds right. Yep.
Yeah, and I remember that. See, that stands out to me, even though I didn't really understand the technology behind it. So I do have to say you are an amazing speaker, somebody who obviously knows. So else, I've never taken so many notes in a talk. That was amazing. That's from James McDermott.
Take notes. It's all in the article.
That too. And Snon Bergowski just says thank you. As well. I do have to say, Laura, just in regards to, I'd love to just hear about, you published a book, dude. Like, that's huge, like twice. You know, that kind of you huge accomplishment. I
didn't publish the whole. I didn't publish the whole books. I contributed chapters.
You contributed to it, but I also think that's really an amazing thing to have and such a huge accomplishment. I'd love to just hear a little bit more about that, or how you found that experience, and how you went about it.
Yes, although I want to just quickly say to Oisín Quinn that he definitely wants to be an SRE. It's a really interesting career. I could talk a bit more about that actually if there's no more questions after this. But yeah, the book. So how that happened originally was I was at Google. It was, what year was it? It must have been like 2015 or so.
Okay.
And my manager at the time was a guy called Niall Murphy. And Niall Murphy was the person who was putting together the Google SRE book, which had this huge impact at the time. It was like as many bestseller many times over, and has been inducted into the Cybersecurity Hall of Fame and a bunch of good stuff like that. And I had recently done my first master's degree of 3, of which I'm currently doing.
Wow.
So my first master's degree was at UCD, and it was the Advanced Software Engineering MSc. And I had written a paper on operating distributed consensus systems, and I cut that paper down. That was my thesis. I cut that down as my chapters of the book. So weirdly enough, it's actually really hard to cut something down to 50% of the size. So yeah. Oh, Niall is the founder of UCD NetSoc. I didn't know that. Brilliant. Yeah, no, I'm still good friends with Niall actually. Niall is, I think he's writing some more books. So
wow.
Anyway, so Niall and some other people at Google put together that first book. So that was my first sort of experience. It is, I will say, I love having an editor. I'm pretty confident in writing, and I usually find I'm fairly lightly edited, but it's really nice to have an editor so somebody can say, hey, this comma is in the wrong place, or you should rephrase that. It's a super helpful process, and O'Reilly are very good with that. Then the other ones were kind of similar things. I think once you've got your name out there a little bit, people will just ask you to do stuff.
Okay.
And writing a book chapter is not that much different to, say, writing an article, which I do fairly often. I write for, there's a magazine. I'm part of the Usenix Association, which is a professional association focused on kind of this. We're sort of split between like systems researchers and industry practitioners in the likes of SRE and security, with a lot of people in security, stuff like that. If you're going into SRE, you should probably think about joining Usenix. But where was I? Yes, so I write regularly for that. So you can develop a habit of writing pretty much on demand. After a while, you just have to be very disciplined about writing down. Like you have to have an ideas file that you can draw from to pull things from when you need something to write about. So.
I think Donald's asking, please talk more about SRE.
So SRE is site reliability engineering. Some people would just say, well, it's just sort of another fancy term for DevOps or for sysadmin. And on some levels, it is absolutely very similar to DevOps or sysadmin. In the way I think about site reliability engineering is that SRE has a big focus on deeply understanding systems and thinking about systems as a whole, the way things interact. Whereas sysadmin will be, more focused on, well, traditionally will be more focused on your sort of your bread and butter things like how do I do automation to make sure that my boxes are all updated and have updated root certs and all this kind of stuff. So different. I mean, you need both. You need both skill sets. It's a different focus. You don't always need SREs if you've got a fairly small service or you're not very focused on having huge uptime. Then you probably don't need SREs. You need SREs when your systems get big and hairy. So I got into it. I was a Java J2E software engineer for the first few years of my career, and then after some time of that, I kind of said, okay, well, let's move on and find new challenges. I went into doing more software performance stuff, so doing load testing and tracking down, causes of slowness and debugging lock contention issues and this kind of stuff. And I worked for a company that was called Guilt Group, and they're still around. And Guilt had a crazy business model where they would DDoS themselves every day. It's called a flash sale. So great for business, hairy for the technology. So my job was to make sure that daily DDoS did not take us down. And that was how I sort of started down the path towards SRE. My next job after that was SRE at Google. So,
wow. Okay. Andrew wants to say, excellent talk, Laura. Really applicable to some of our work in Civica Northern Ireland, where we're working with public sector bodies who are moving towards and adopting shared services. Interesting to consider this in a context where the full stack is split between multiple parties.
Andrew is extremely right. It's very hard to make a system very reliable when responsibility for different hubs is or different layers is split. You lose sort of visibility and context, and it's so easy to trip over limits in the other part of the system that you don't know are there. And this is something that absolutely happens in my current job. For example, it's very easy to trip over a limit in your cloud provider that you didn't know existed. So I don't know if anyone's come across some articles I've written for the Slack engineering blog about times this has happened to us. But yeah, and that's another example where you have responsibility for a system split over two organizations. It's a real problem. I think the only way to solve it is, really great communication and, maybe a lot of load testing.
Perfect. Laura, I'm just curious in regards of, like I said before, I feel like you've accomplished a lot in your career this far. Even just talking about, you spoke at ShipItCon in 2019, where I was hosting, and it's 2021, and it seems like you have made more leaps and bounds than when I introduced you the first time. So I'm just conscious, and I would love to know, so because of the fact that a majority of our attendees today are students, what are some of the challenges that you faced getting to where you are now, and what advice do you have for them as well, just in regards to whether it's switching into site reliability engineering or switching out of it, or even if they want to collaborate one day and be able to contribute to a bestseller? Would you be able to share any insights? Because I'm also going to be taking notes, but feel free to address it to the tech students first.
Yeah, I have two big messages. So I think the first big message is going to be these things take time. It's a marathon, not a sprint. The start of my career was actually really rocky. I had a very bad time. I graduated in 2002, which was right into the teeth of the .com bust. And that was very, very tough to find the first job. I spent 9 months with a first in computer science from Trinity, and a bunch of internships and stuff. I spent 9 months temping. then I ended up getting a job in automated testing, and in that organization, I eventually worked my way up through the ranks of the software engineering levels. So it took a little bit of time to get started, and I think that's actually relatively common. But don't be discouraged, because I think the industry does have a way of sifting through people, and I think if you keep at it, you will get there. I would say in the current environment, anyone who's going to be looking for a job in the next year or two, I would highly advise having a portfolio of some kind, something that you've done. Find an internship or somewhere you can volunteer or contribute to some open source projects. There's a lot of opportunity to do that, and that gives you something that will make you stand out a little bit. So I highly recommend that. Then the other thing is, technology and software is huge and broad, and I think once you figure out what part of technology you love, go all in if you can on that. And that's what I did with SRE. I love to think about systems and how they hang together and how they behave. And I'm also very interested in failure and learning from failures, and using them to make our systems better. So that's what makes me excited about technology. More so, like I don't know if I will be as happy doing something else. Like I don't know if I'll be happy being a front end engineer, although that's a very fine thing to be. That's not what I am. So I think there's a lot to be said for finding something that's that suits you, and go all in on it. That's what I think.
I just want to follow up from what you said there, just in regards of a portfolio, get involved in projects, internship, volunteers. I feel you have a wealth of experience behind you, so your expertise is usually sought out to collaborate on projects. I'm just wondering, how would a student maybe approach that aspect of trying to get involved in projects, or are there any resources that you would recommend for students to just maybe get, start kind of looking at and, keeping in the forefront? Or if there's, I know GitHub is one of them, but I don't know if it's the most accurate or the most up to date. Or is there a platform that you would recommend for students?
Yeah, I think what you would do would, again, depend a little bit on your interests. Like if for example, you're big into databases or systems, you might go and look at a database project and see if they're looking for volunteers. I mean, almost all open source projects are looking for volunteers all the time.
Okay.
And it can sometimes be quite easy to get involved. I mean, they all have issue trackers, and so you can dig through and find something that doesn't look like it's too difficult to do. You could even start off working on documentation. That's something that a lot of open source projects will struggle to get people to do. So if you're comfortable going through reading issues, reading code, you can do a lot there. And not all projects are huge. Some of them are smaller and simpler. But they still need maintainers. They absolutely do. In terms of other kinds of volunteering, it depends what your specialty is. Like if you're into sort of network and sysadmin, like you might easily find small voluntary organizations needing help. Like these definitely do exist. You'd be most likely to get that through existing contacts in those kinds of organizations, I would think. A lot of small organizations will have somebody who's doing webmaster or that kind of thing. So, someone in the chat is mentioning Coder Dojo. Yes, if you like teaching, it's an excellent thing to do. Those kinds of things. So there's definitely opportunities. Do not underestimate the power of having great communication skills. And that is what volunteering as a teacher will give you. Being able to communicate well being able to communicate in a spoken way and particularly in writing is one of the key skills that gets people from being an average engineer to being a senior engineer, because once you can communicate, you have that leverage over teams, right? Being a lead is not about being the smartest. It's about having the judgment and the ability to communicate trade-offs and risks and helping your team to come to the best conclusion. I mean, that's what I do as a TL. I am not the smartest. I'm not the smartest person on my team. Like a lot of them are really, really, really smart. But what I'm good at doing is I'm good at articulating trade-offs and articulating potential pitfalls and figuring out, helping the team become one single brain as opposed to 10 brains. That's what I do. And you can start down that road by doing something like Coder Dojo. It's a great idea.
Yeah. So sorry, because you were talking about, so Simon was asking about, could you give some examples of volunteering because they're not familiar with volunteering in the tech sector? And then Stephen, who is from Microsoft, also had to say something. But Clea wanted to say, what would you recommend someone coming from a general computing degree should learn about if they're interested in becoming an SRE?
Great question. So lots of people coming into SRE will have a general computing degree. Some people, and plenty of SREs don't have a computing degree at all. Niall, for example, his first degree was in poetry.
Wow.
Yeah. So there's hope for anybody. However, what I would recommend learning about TCP. Learn about networks, TCP. TCP is really interesting because networking is a big distributed system, and so much of TCP is about sort of trying to moderate the behavior, and a lot of the same kind of themes of backing off and retrying, and that we've been talking about in this talk. So I think studying TCP will give you a lot of sort of that systems thinking stuff. And studying Linux is always good, and then study things like load balancing and study things like how to write good safe automation. Study systems administrations. Huge amounts of stuff written about good practices there, and good SRE should know all that stuff too. Then there's a really good book called Data Intensive Applications. I'm trying to remember who wrote that. It's probably behind me somewhere here. Read stuff about distributed systems. There's a bunch of books there now. There's an awful lot. But yeah, I would start with TCP.
I have a question because I have a little brother who's studying information systems and he's thinking about going down the route of IT, and he's probably going to kill me for asking this, but I'm curious just in regards of the types of opportunities that are available, and how do you ultimately make your decision? So you've talked a lot about SRE and kind of what you've come through and what you've experienced, but how did you ultimately decide that this was the area that you wanted to go into? I know, you studied and then you went to college and you did temp work, and maybe I always feel that life experience in temping does give you that little bit of exposure to any and everything. So you really get to choose, like, I like that, or I absolutely hate that and never want to do that for the rest of our life. But I'm just curious, how would somebody who maybe was just starting off in school, whether first or second year undergraduate degree, a lot of information is being thrown at them, not to mention the current situation of what's happening outside is impacting that piece. So I would just be curious from yourself, Laura, what advice would you give to somebody in that position?
Yeah, that's really tough. I've been hit by this as well. Like my ethics degree went online last March, and I won't be in the classroom again. But so I have a lot of sympathy with that. So how to sort of choose? I think just to a certain extent. You're going to have to try some things, and there's no way around that. I don't know what the situation is going to be with internships for people who are doing things now. A lot of people just hop between jobs early in their career. It's not a horrible idea. If you join somewhere and you don't like what you're doing or where you're working, it's perfectly okay to change jobs after 18 months or 2 years. That gives you sufficient time to know if you're going to like that position or not. One of the great things about technology is it's relatively easy to pick things up and try things. There's so much information now, there's so many books, there's so many articles. Like I say, open source gives you a real opportunity to get involved in a lot of different kinds of toolings. So I think in terms of professions, computing is one of the ones that I think gives you a great diversity of options and reasonable access to those options. Doing further education is a thing as well. Obviously, not every area really has further education. Sometimes there are certifications in areas. I don't have a huge opinion on certifications, but they can be useful for deciding if you've got an interest in, say, networking. If you go and do a chunk of your CCNP, you'll know if you are or not. So that's an option in some cases. But yeah, I think the real proof of the pudding is, when you get a job doing something, is it something that speaks to you or not?
Really insightful. I just in the chat there, I know it was a Stephen Howe was in there, so I was just getting his, but he says, I think Laura is saying everything I would say, only better. So hats off to you, Laura. I don't know if anybody else wants to ask any more questions. We do have Laura with us for another 5 minutes. So if you guys are interested in asking questions, and being able just to interact with her and engage. I do have to say that the speakers from today you guys have had a huge amount of knowledge. It's almost as if you've been in this field since the very beginning. Honestly, the way that you delivered from presentation to the expertise and the knowledge as well, it's truly inspiring. Almost makes me regret doing my psychology degree and completely ignoring tech, because I was always like, no one can ever replace the human touch. I always need to work in an area with people. And now I'm noticing, but I do think it's absolutely amazing. Obviously, the advancement of technology is allowing us to, automate a couple, really free it up. We mentioned about upskilling as well. There in one of the other presentations, I'd just be curious to get your insights on it as well. What areas do you think we're going to need to upskill in, specifically within technology? So the current roles that are there at the moment, and then thinking about upskilling and maybe things that are kind of being phased out. But what type of roles or what upskilling do you think is going to be necessary over the next couple of years?
That's a great question. Obviously, technologies and frameworks are changing constantly. It seems to be even, particularly more true in the front end space, which I think is a huge challenge for people in those areas, but that isn't my particular area of expertise. I would say in my end of things, actually, what's nice is that the technology set has sort of stabilized. There hasn't been anything terribly new that's going to come down the line. Kubernetes was the last big sort of disruptive thing. Which is, I think, still being digested. I will admit, I don't spend an awful lot of time thinking about what's going to come next to the industry. I sort of roll with the punches and try and sort of tend to my own systems. So I tend to think that the bread and butter of, you just said it there a moment ago, right? The human touch is the most important thing, and that speaks to me, because I think even when we're thinking about software systems, right? The human understanding of how does my system work, what are its weaknesses and strengths, and how am I going to evolve this system over the next year or two, however long, right? That's the thing that matters to me more than am I going to go on Kubernetes or not. So I don't spend an awful lot of time necessarily thinking about specific technologies so much as I do about the system, if that makes sense. So what I would love to see coming down the line in the industry is more systems thinking and more communication.
More systems thinking and more communication. I like that. Okay, so I'm going to ask you one more question, and then I promise I'll get you out the hot seat. What is next for you? What are you doing next? What are you contributing to? Those who follow you, they will probably obviously are going to be interested to find out, what is Laura Nolan getting into next? What is she going to come out with? What's the next accomplishment? So can you, if you can, divulge a little bit about maybe what it is that you're going to be getting in? That smile makes me feel as if you're like, I can't tell you.
Well, in all honesty, I'm writing up a master's degree thesis at the moment. So
okay.
It's something that's
best of luck with that, by the way, because I know how hard it can be. So I'm sending you positive affirmations, positive vibes, whatever you need, literature review, information, research, just so that you can get through that successfully and not have a mental breakdown in the midst of it. So yes.
Working full time in a pandemic, also writing a master's degree. So yeah, that's going to be enough for a little while. After that, I'm not sure. There's always a lot of, work is always, it's always an adventure, something new every week. So there's always a lot to keep on top of. I'm committed to staying. One of the projects that we're doing in Usings at the moment is we're taking the publication that we do, Login. It was a quarterly magazine. We sent it out print just to the members, but we've now taken it to a publicly available, well, very shortly it will be publicly available, open access, just there on the internet. But I do really value that publication as a source of really deep content about systems administration, DevOps. And one of the things I'm doing is helping the person, Rick, who has been editing it since day zero, decades ago. I'm helping him sort of set up a committee of volunteers from the community, and sort of helping to sort of essentially unburden him from being the only person looking after this thing, because he's been, he's approaching retirement, so we have to sort of figure that out. So that's something that's taking some time. Other than that, I'm not big on forward planning, I will admit. It's not all the time. I did have it, 10 years ago I had a big career plan, and now I'm sort of like, well, I'm here now. I'll just, keep all the balls in the air.
Yeah. You remind me of a lecturer that I had that I really truly admired, because she'd been working in education for a really long time. And she's known as an expert in her field. And she says that it's no longer about a career plan or a job. It's more about what projects excite her. Yeah. And that's how you make the decision ultimately of what are you going to be doing next? Because you always have a date where it's going to end. So Laura, I want to thank you from the bottom of my heart and from all of our audience today. Thank you so much for joining us. Thank you for contributing, for participating, for educating and inspiring us. That is honestly the main theme of today. It's my first time hosting a system conference. With them, I'm impressed. I'm absolutely blown away. But the one thing I do have to say is that each and every single speaker, I've been able to walk away with some keynote piece or a golden nugget, I've been calling them all day, of inspiration. So I do want to thank you for being a part of that, and for obviously providing a huge amount of value to this discussions we were having today.
My pleasure. Thank you for having me.